Hello everyone, today let's solve the problem number 33, search an rotated sorted array, right? So what the question states here, we are given an sorted and possibly rotated array nums. You can clearly see here, we are given an sorted and possibly rotated array nums. We have to find the index of a given target. So we have been given target as well, target integer. So we have to find the index of given target. So here in this case we have been given 0. So here first we need to check whether 0 is present in the nums array or not. If the target is present in the nums, then we have to return the index of the element that is present, index of the target element that is present in the nums array. In this case, if we count 0, this is 0 indexed array, right? First thing that you need to keep in mind here is this is 0 indexed array. So 0, 1, 2, 3, 4 here. So it is present at the 0 is present at the index 4 here in this case. So we need to return the index, right? So here in this case output is 4. So if target is not found, then we have to return -1. They have given here, if target is not found, then we have to return -1. Means suppose, let's come to the example 2 here. So we have been given target 3 here in this case, right? So we have been given target 3. First what we will do, we will check whether 3 is present in the nums array or not. So here you can clearly see this is a rotated array, right? Sorted and rotated array. This is rotated 4 times, 4, 5, 6, 7. You can clearly see 0, 1, 2 is present, but 3 is not present here. 3 is not present in this nums array, in the nums array. Basically, in this, so for this one, what we need to return here, -1. They have strictly mentioned in the question, right? So if target is not found, we have to return -1. They have said in the question. So let's come to the third example here. So we have only single element here, nums equals 1, only one element, and target we have been given 0 here. In this case, output is -1 here in this case. Why output is -1 here in this case? Because we have only one element in the nums array. Target is 0. Quite obviously, how many times you search, whatever you do, you will not get the element 0 in the array, right? So the output at that point, if the element is, if the target is not found, then we have to return -1, right? We will be returning -1. So that is how we got -1 here. This is fine, simple to understand, right? They have given examples wonderfully, just for the understanding purpose here, right? So I hope this is clear. So I hope the question is complete. Completely clear. What we need to do is completely clear as well, right? So first, what we will do, let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. Here, the first thing that we need to observe here is we will be going with a binary search. So they have asked in the question to write the algorithm on big of logarithmic n time, big of log n, this one, right? Time complexity. So we'll be going with the binary search. They have strictly asked in the question to find, write the algorithm to find the solution on big of log n, right? So that is the reason we'll be going with a binary search, right? So I have considered the first example that they have given in the question. So we have already discussed this one. It will be easier to understand the approach. That is the reason I have considered the first example that they have given in the question. So here you can clearly see we have 4, 5, 6, 7, 0, 1, 2 in this case, right? So we have 4, 5, 6, 7, 0, 1, 2 in this case. Target we have been given 0 here in this case. We have to find the index if target is present in the nums array, right? So this is first index, this is 0th index, 0 index, right? 0 based indexing. 0, 1, 2, 3, 4, 5, 6. So 0 is present at the 4th index. We are returning here 4 in this case as output. I hope this is clear. Simple one, right? So let's discuss the step-by-step execution here. First, so I've considered the first example, right? The same example here. So we are going with the initial pointers. We have to initialize the pointers. First thing is left equals 0. We are making use of the left and right pointers, 2 pointers here in this case. Left equals 0, nothing but the first index, starting index. Right equals 6, nothing but the last index. See here, we have already discussed 6, the last index, right here. This one is the index, the last index, right? So the left pointer is pointing to the starting index and the right pointer will point to the last index here. Mid is 3. 0 plus 6 by 3, mid is 3. So 3, this one is having the value 7 here. This one is mid, right? This one is left and this one is right. This is fine. So here in this case, nums of left is 4, nums of mid is 7 and nums of right is 2. We know this one, right? We know this one. We already know this one. This is fine. So let's move on with the second step here, the first iteration. So the first iteration, we are going with the left half. So we are going with the left half here in this case. We are considering 4, 5, 6, 7. So we are considering 4, 5, 6, 7 here in this case, right? So we are considering 4, 5, 6, 7 in this case. So here in this case, 4, 5, 6, 7 is sorted, right? So 4, 5, 6, 7 is sorted in the ascending order. You can clearly see 6, 7 is sorted. Since 0 is not in 4, 5, 6, 7, so we have to find the 0 itself. Target is 0, right? So target we have been given 0 here. We have searched the first half or the left half here, 4, 5, 6, 7. Since 0 is not present here, right? 0 is not present in the 4, 5, 6, 7. We have to search right. So we will be going with the right half. Right half. We have to search the right half, right? So now left equals 4 in this case. Left equals 4. This one. Left was 4. We have to find the right half, means 2. The last element, the right pointer was pointing to 2, if you remember. So now left is 4, right is 6, mid equals 5. Nothing but value 1. Mid equals 5, nothing but value 1. This I am speaking of. Just give me a second here. Mid equals 5, value 1. This one I am speaking of. We have to search the right half, right? So just give me a second. So sorry. So I did not this one. This one I'm speaking of. Left equals 4 means 0, 1, 2, 3, 4. Fourth index. So I got confused here. Sorry. Left equals 4 and right equals 6. This one. Right is 6. Left equals 4. Right equals 6. Mid is nothing but this one is mid. Mid is nothing but 5 with a value 1. Right? So this is fine. So I got confused here. Sorry. This is fine. So left half 0, 1 is sorted here. This one we are speaking of here in this case. 0, 1. This one. So this is the last element, right? 2 is the last element. Here in this case, 0, 1 is sorted. Right? So the left half I am speaking of. The left half 0, 1 is sorted. Then we have to search left in this case. Right equals 4. So right equals, we have been given 4 here in this case. Now the right is 4. This one. Right equals 4 now. This is fine. I hope this is clear. Let's come to the third iteration. Easy to understand, right? Pure binary search. Here in this case, now left equals 4, right equals 4, mid equals 4. Now we searched, first what we did, we searched for we went with the mid. We also went with this one, right and the left element. We searched with the left element. We got 4 here, right? So everything, now left is at the 4, right is at the 4 and mid is at the 4 as well. And we are having the value 0 here in this case. Now we have the value 0 in this case, right? So target is 0 as well. Target is 0 and we found the value 0 here in this case at the index 4. So we will be returning the index here in this case, right? So we will be returning the index. So since the nums of mid now equals target, then we have to return 4 in that case. So this matches the target, right? So the value matches the target. So we will return 4 in this case. Simple. So the final output that we got here is 4. This is how we got the final output as 4. Simple. Pure binary search, right? So this is the approach that we will be going with. So now we are familiar with the approach. So the output that we got is 4, which is equivalent to the output that we that they have shown for this one, example 1. So the approach works absolutely correct in this case. So this is the approach that we'll be going with, right? So now we are familiar with the approach. Let's discuss the edge cases one by one. So the first edge case here is target in the left half, right? So the first edge case here is target in the left half. When I say target in the left half, this is the sorted region I'm speaking of. Here nums we have 4, 5, 6, 7, 0, 1, 2. 4, 5, 6, 7, 0, 1, 2. Target we have been given 5 here in this case, right? So the output here is quite obviously 1. The output here is quite obviously 1. Why the output here is 1? You can clearly see here, 0, 1. So we got here itself. This is 2, 3, 4, 5, 6. So this is at the output 1. So first what we'll do, we will make use of the binary search, or we will perform the binary search in left half, and we will find the value at the index right? So we need to return the index. So here the output is 1, right? So this is, I hope this is clear, the first one. Let's move on with the second edge case here. Target in the right half, nothing but sorted region here. In this case, target we have 1. In this case, 1, 2, 3, 4, 5, 6, 7. Sorry, it has to be 0. 0, 1, 2, 3, 4, 5, 6. So this one is present. 1 is present at the fifth index. We have to return 5 here in this case. So target is present in the right half. So we will perform the binary search in the right half, and we will find the value at the index 5. So we need to return 5 in this case, right? I hope this is clear. Let's move on with the third edge case here, target in array. So here target is 3 here. Target is 3. So this is not target in array, target not in array. Sorry, target not in array. So the element or the target element is not present in the nums array here. In this case, in the question, they have clearly mentioned if the target element is not present in the nums array, then we have to return -1 in that case, right? So here we'll return -1. Let's move on with the fourth edge case here. Array is not rotated. So when I say array is not rotated here, you can clearly see this is purely sorted, right? Cleanly sorted. 1, 2, 3, 4, 5, 6, 7 in the ascending order. Array is not rotated at all here. Target we have been given 6. Directly we can just give here 5. When array is completely sorted, we just have to go with the element -1 for the index, right? So as it is 0 based indexing. So here in this case, 6 minus 1. So if it starts from 1, if it starts from 1, I'm speaking of 6 minus 1 is 5 in this case. So the output will return it as 5. So this is fine. Let's move on with the fifth edge case here, single element in the array. So we have only one element, that is nothing but 1. Target is 0. So target is 0, but the element is the element that we have in the nums array is 1. However, we search here, whatever we do will not get the target element in the array because we have only one element, that is 1. But the target we have been given here as 0. In this case, we have to return -1 as output. So these are the 5 edge cases that we need to keep in mind, right? So the first edge case is for target in the left half. The second edge case is for target in the right half. The third edge case is for target not in the array. The fourth edge case is for target array is not rotated. Sorry. The fifth one is for single element in the array. These are the 5 edge cases that we need to consider, right? So I hope the edge cases are completely clear. Now we are familiar with the approach as well as the edge cases. As we are familiar with this one, approach and edge cases, it will be easier to write the code. Let's start writing the code. So first thing here is we have to initialize the search range. Nothing but we'll be going with the 2 pointers on this case. So I'll just initialize left to 0 and right to length of the nums -1. Nothing but nums dot length -1 here on this case. This is fine. So the next step here is we have to continue the binary search until the range is valid. So always I'll just go with the while loop here. Left has to be less than or equal to right. So this has to be always true, right? So that is the reason I'll be making use of the while loop here. This is fine. So we have to calculate the middle index. So for calculating the middle index, I'll just go with mid equals left plus right minus left here by 2, right? So this is fine. So the next step after calculating the middle index, if the mid element itself is the target, then we have to return that particular index itself, right? So for that one, let's articulate the same thing in the form of code here. I'll just give here nums of mid here. If it is equal to the target, then we have to, what we need to do here, in that case, we have to return that particular index itself. Nothing but we have to return mid itself. This is fine, easy to understand. So the next step here is, suppose the left half is sorted. So suppose left half is sorted, then we have to search in the left half, right? So that one we have to articulate in the form of code. We are just going step by step. Whatever the thinking process or whatever we discussed in the approach, same thing in every problem, we are articulating the same thing in the form of code here, right? So if the left half is sorted, we have to search in the left half, right? First thing here is if nums of left, this one is less than or equal to nums of mid. In this case, what we need to do, I'll just make use of if condition here. Nums of sorry, this has to be nums of left, right? Nums of left less than or equal to target and target less than nums of mid here in this case. So this one we have to search in left half. Means I'll just give here right equals mid minus 1. This is fine. Right equals mid minus 1. Else what we need to do? I'll just give here else we have to search in the right half. So else we have to search in the right half. I'll just give here left equals mid plus 1. This is fine. So next step, one more thing, if the right half is sorted. So here this is fine. Till here this is fine. Here this is for the condition. So if this one, if the mid element or if the mid index itself is the target, I mean if the mid element itself is the target, then we are returning mid in that case. If the left half is sorted, then we are searching in the left half, else in the right half. This is fine. Then there is also one more condition, that if the element is present in the right half, or if the right half is sorted, then we have to search in the right half, else we have to search in the right half. That also we have to write, right? So I'll just come here in this case. So I'll copy the same thing here, this one, and let me make the necessary changes here. Let me give else here. So this one, within this one, let me paste the same thing over here. This is fine. So here, if nums of this one, if nums of mid, so let me write this one. Let me write this one itself. If, so we don't get confused here. So if nums of mid here, so if the right half is sorted, right? If nums of mid is less than target, and if target less than or equal to nums of right in this case, this is fine, right? So then we have to search in the right half, nothing but left equals mid plus 1 in this case. This is fine. So else what we need to do, we have to search in the left half. So I'll just come here, I'll just give here else. So let me give here else. What we need to do, we have to search in left half. So I'll just give here right equals mid minus 1 in this case. I hope this is clear. The final step here is what we need to do. If the target is not found, if the target is not found in the nums array at all, so in that case we have to return minus 1. We have to return minus 1. I'll just give here return minus 1 here, right? So this is it for the code. So we just articulated our thinking process or the approach in the form of code here, right? So what did I do here? So this one, let me cut this one. Just give me a second here. Let me cut this one. So somewhere I missed something. I don't know what I missed. Just give. So here in the line number 11, I have missed bracket here. So this is where. So I'll just give one more bracket here on this case. So let me format the code once, and here after this bracket, so if the element is not found in the nums array, if the target element is not found in the nums array, we have to return minus 1 in that case. So I'll just return minus 1 here, right? So let me hit the run button. So let me hit the run button, right? So here you can clearly see the sample test cases are getting passed. Means the code works absolutely correct in this case. I hope the code works absolutely correct for all the test cases. Let's see. I have hit the submit button. Let's see. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So I had just missed the bracket here. In the line number 11, I had missed the bracket here. So that is the reason. This is fine, right? So let's quickly discuss the complexities for the code that we have written. Right. First thing, the approach that we went with here is binary search on the rotated sorted array, or we can just call this one, we were performing the binary search, right? We can just call this one binary search, the approach. So overall time complexity here is big O of logarithmic n. So overall time complexity here is big O of logarithmic n, right? So what would be the space complexity here? The overall space complexity would be big O of 1. So the overall space complexity would be big O of 1. So the time complexity here is big O of logarithmic n, and the space complexity would be big O of 1. So for the code that we have written, so overall time complexity and the space complexity for the code that we have written is big O of logarithmic n and big O of 1 in this case, right? I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching.